All right, good afternoon, everyone. So this week, we are going to start on loops. Before we do that, spring break's coming up. So just be aware, for those that weren't, next week is spring break. We won't actually have class, but now that the midterm is over, judging by the results, at least of the vocarium part, I think it's fair to say that some of us aren't as proficient in programming as we should be by this point in the semester. That's okay. This class is here for you to learn. That's what it's for. What I wanted to do for now, just a couple minutes, is just take a moment to point out some resources that are available to you if you feel like maybe you're a little overwhelmed, maybe you need some more help, just in case you're not aware of them. So resource number one, I'll start here and I'll go backwards. If you go to AU Access and look up classes, there's actually a lab that goes along with this class. It's Comp 1201-021. You can't click the button and enroll now, but if you like, this is official course, so you have to enroll in this. It's a 1 credit hour course. It's pass fail, satisfactory, unsatisfactory. It doesn't affect your GPA at all. I made it that way on purpose because the whole purpose of the class is just to help you succeed in here. So the content they cover mirrors what we cover in class. So we talk about loops, they talk about loops. The TA that came and did the exercise with you the other day, he's the one that leads the lab. He's really helpful. And that's your lab. If you ever have a question, let's say you're having maybe everyone in class, this assignment's too hard, we're having a difficult time. That's one thing he's done before. Okay, let's talk about it. Let's open it up and just look at it together. If there's a concept you're struggling with, sometimes he'll go over that. Aside from that, we have the quizzes on one day, and it's more of a conversation piece, if you would. Ask you some questions where you can kind of see the areas you're deficient at, right? You have these questions, and if you're unable to answer them correctly, okay, I'm kind of lacking here a little bit. And then the rest of the class is discussing those answers. What do we answer? Why'd you pick that? And here, clarifying that information. And then the other day is something practical, kind of like an exercise, like we do in class, where you have an exercise you do together, like the ungraded ones that we do in here. So option number one. Option number two, Auburn University in general, I think this is through the library, has something called study partners. And you can arrange to have someone tutor you. I don't think there's a charge for that. There are limited slots though, but you can sign up to have someone tutor you if you feel like that's what you need. And finally, the engineering department offers their own tutoring. I think they call it peer tutoring. And I just Googled Auburn engineer peer tutoring. That's all I Googled. And it'll take you to this page here, and you can see how to make an appointment. They have two types of sessions. They have individual sessions and group sessions. So individual sessions, you need some one-on-one time with someone. Group sessions, they do 1 or 2 times a week, and they'll accept, they're limited in space, but they'll accept 5 or 10 people, and they'll just cover some concept. Maybe this week they'll talk about for loops. They'll just talk about it with 5 or 10 of you, whoever happened to be there. So those things are available to you. The other thing I would recommend, I noticed that I know the assignments aren't due until the end of the semester. My intention with that was not so that you would wait to at the end of the semester to do the assignments. It was meant to be flexible in case something happened. We always have something come up. Maybe someone gets sick, someone can't complete it for some reason. That's fine, no problem. You have to the end of the assignment or the semester. Or some of us, myself included, I learn slow. That's always been that way. I don't learn things as fast as other people do. So by allowing you to turn it in on the end of the semester, you have plenty of time for that to catch up in your brain, if you would. And then you can, maybe you just didn't get it the first 2 weeks of class, but you did get it by the end, and you have a chance to submit it and get a good grade on it. That being said, I would encourage you, I know it's a lot to do, but I would encourage you to try to at least keep pace with class. So when the assignment is technically due, try to finish it by then. The purpose of the assignment is really to help reinforce what we're talking about in class. So the way the class is structured, I talk, and some of us, sleep, some of us listen. And then we have an exercise where you practice what we just talked about. So you can kind of reinforce that idea. And then you have a homework assignment where you further reinforce that idea. And then of course, somewhere in the middle, you have Zybooks that you're going through and reading for more learning, right? So you have the lectures and the books for that learning. And then you have the exercises and the actual assignment to reinforce that and really help you grasp that idea. So I won't take too much more of your time, but I did want, again, I just wanted to make you all aware of those resources and encourage you to try your best to keep pace with the assigned activities in class if you can. Even though they're not required, I would encourage you to do that. I think it would help. All right, let us get back to class. We are on loops. And it's about to start getting really interesting, or at least we're about to start be able to do really useful things. I think one more chapter, once we get to arrays, we'll start, you'll see that we can do some really useful or interesting things with C as a language. So repetition, here's a funny comic that I think demonstrates the idea behind repetition well. So this, I don't remember the name of this cartoon character, comic character. They did something wrong, and the teacher wanted them to write, "I will not throw paper airplanes in class" on the chalkboard 500 times. So what the student did was he wrote it in a for loop. For, count equals 1, count less than equal 500. Here's what I want you to print. This looks a lot like C, right? It is C. And basically, he was able to write it one time on the board, and the idea is that the loop would repeat that instruction 500 times. So he only has to do it once. He doesn't have to do it 500 times. And that's the idea behind how repetition or iteration works in a programming language. If you have one instruction that's either, in this case, it's just one single instruction that you want to do multiple times, or maybe one instruction that's just slightly different, right? You want to execute slightly different variations of that instruction. Why do you have to write it 500 times? That's painful. You can just write a for loop, put it in there one time, and then let the computer handle repeating that instruction for you. Let it handle that tedious work. So we'll start with our simple definition. Repetition, or perhaps iteration, is a better word because you're not always repeating something. Repetition or iteration is repeating a task or a group of tasks until some terminating condition is met. So you got to tell me when to stop. And until I match that condition, I'm just going to keep repeating this instruction. That's the idea. So here's, I really hate it that always happens with no warning. Okay, online students, give me one moment. My projector closed again. I'm sorry, I have to wait 1 minute and 10 seconds before I can turn it back on again. All right, here we go. So what are some examples of things that might be repeated? So here's a simple one. Let's say we wanted to sum up a list of values, right? So in this example here, suppose we had these three variables, X, Y, and Z. We might make a separate variable that we can store the total sum in. And we could write something like this: sum equals sum plus X, sum equals sum plus Y, sum plus Z. And we could go on. If we had 100 variables, we could do this instruction 100 times, right? We might not want to do that. So perhaps instead of storing this information in individual variables, we can store it in something else. We'll learn about arrays in the next module, but that's what we're looking at. We could store this in something like an array, and then we can just write one instruction: sum equals sum plus whatever's in the next position in the array, right? And now above it, we have some type of statement that controls when we stop. In this case, I want to stop when I repeat this 3 times, and it'll control how many times that instruction gets executed, right? Maybe it's 4 or 5 or 100 or 200 or 1,000. And we definitely don't want to write that 1,000 times. There are 2 types of constructs that we can use to do iteration in C. I know I have 3 things on here, but there are 2 types. There are for loops and while loops. The last 2 are variations of each other, kind of like an if statement or an if else statement, right? So a for loop is typically used when you know how many times you're going to repeat something. So if I know I want to repeat it 10 times or 20 times or 30 times, I know exactly how many times I want to do it. Or if you're able to calculate how many times you're going to do it, right? So maybe you don't know it's going to be 500, but I can put an expression in here, and I do have a way to determine an exact amount of times I want this to happen, right? I have a way to specify that. Then you would want to use a for loop typically, and note that you can use either loop interchangeably. Depending on how you write it, you can use one loop and it'll behave like the other one, but they are made to behave a certain way, and it's typically easier to use them if you use them the way they're intended. So a for loop is intended to be used when you know how many times you want to do something. A while loop is meant to be used when you really don't know how many times you're going to repeat something. Maybe not at all. So let's say, for example, I think I have, okay, in the while loop. Let's say, for example, we're going to make a program that'll just ask you to guess some number, right? Pick a number 1 through 10, and as soon as you guess the correct number, I'll stop. I really don't know how many times you're going to guess the wrong number. Theoretically, you'll make 10 guesses and one of them will be right. But maybe you guess 5, 6 times, you keep guessing 5 over and over again. And I really don't know how many times you're going to guess until you get the correct number. So in that case, I would use a while loop, because I don't know how many guesses it's going to take for you to complete the task. And finally, the last variation here, the do while. The while loop, there's no guarantee that it'll happen once, right? So the way this works is I have a while and then some if statement. And if this condition is true, I'm going to execute these tasks. So you can think about a while. You can think about it like an if statement that repeats. It behaves exactly like an if statement that repeats itself. Imagine you had an if statement, and we know how if statements work. Imagine you had an if statement, and once you finished, if this if statement is true and you execute all that stuff, you go back and you ask the question again. And if it's still true, you do it, and then you go back and you ask it again. And if it's still true, you keep doing those things. That's what a while loop is. It's an if statement that repeats as long as that condition is true. But of course, we know an if statement can be false, so you may never execute those instructions. The do while loop is a variation of the while loop that always guarantees that those instructions happen once. I promise it's going to happen at least once, whether this is true or not. And then we'll look and see if it's true or false. If it's true, then we'll repeat it. Otherwise, we'll exit. But at least I'm going to do it one time. So the do while is the only loop that's guaranteed to run one time. So let's take a look at a for loop. There's a lot of stuff on the slide, and I've tried to color code these different sections so that hopefully we can use that to help us understand things. So in general, maybe I should do, let's do this. Because this is really cluttered. I want to give you a plain view as well. And we can use, we'll kind of go through an example while we're talking about this. We'll have our generic, our default include statement here so we can print things. We'll do that so we don't get warnings. So a for loop looks something like this. We have these three sections here, 1, 2, and 3. And you can see that down here. You have these three sections. This first section is typically used to initialize some variable to a value. We're going to use this as our, let's call it a loop variable, right? Remember, for loops are used when we know how many times we're going to do something. So this is, this is not exactly what it is, but we can think about this like our counting variable. Okay, this is what we're using to count how many times we're going to do something. We'll just think about it that way for now. Of course, it still has to exist. It's still a variable. So in modern day versions of C, you can do this. In older versions of C, using older compilers, you had to create it, the variable somewhere else, and you could just use it in here. But in general, this section is used to initialize variables to values. You can do more than one. We're just going to work with one in here. This middle section, this is when you stop. Remember, we said that iteration should execute some task until some terminating condition is met. So that's what this middle section is. This is when I stop. As long as this thing is true, I execute whatever's between these two brackets, right? As soon as this thing becomes false, I skip this and I don't execute these instructions anymore. That's what this means. As long as this is true, right? So here's our stop condition. When do I stop executing instructions between line 8 and 10? You stop when that's false. And finally, this last section here, this third section, this is where you modify this. Now, if I never change the value of I, well, 0 is always going to be less than 10, and I'm never going to stop. Right? I'll just repeat this forever. And we can see that in C, whether it's a good or a bad thing, all of these parts are optional. They're not required. So we could do something like this. And we'll just print the value of I. So I'll say hi, and then I'll print whatever I is. And we'll run it for a little while, and then we'll stop it. And you'll see that I is just 0, and it keeps executing over and over again because this is never going to be false. 0 is always going to be less than 10, right? So let's go ahead and stop this now. So initialize some variable, and let's change this to, just so you can see, right? I is 22, but I'm going to change the value here to something else. Doesn't matter what it is. I'll change it to something else, and you can see it is. As soon as I got there, I set that to 0, check my condition, execute the instruction. Check the condition, execute the instruction. We'll just do that over and over again. I do want to stop eventually, right? So we'll use typically this third part to modify this variable in a way that eventually this will be false, right? Now, the way I have this set up, I is 0, check my condition, and I'm just going to increase I by 1. The way this is set up, how many times do we think this loop is going to execute these instructions? Ten times, that's right, 0 through 9, because I is going to be 0. 0 is less than 10. Then I is going to be 1. 1 is less than 10. We'll do that through 9. Eventually, I will become 10. 10 is not less than 10, and we'll stop. So remember what we said about for loops. They're typically used when you know how many times you want to execute something, or you have the ability to calculate it. So in this example here, I know this is going to run 10 times because of the way that I wrote it, right? So we have these 3 pieces. This is where I give my, let's call it a loop variable, some value. Here is my stop condition. I stop when that's false. And here's where I modify that variable so that this eventually becomes false. And then these are the instructions that I execute as long as that condition is true. I only have 1 here. But notice here that I is changing values, right? And we're going to take advantage of this later. But this is something that you can take advantage of. Now you have a variable whose value is, let's say, dynamically changing, but it's changing in a fixed and known way. It's changing every time I repeat these instructions, it's going to change, but I know exactly how it's going to change, and I can take advantage of that. So in this example, if I wanted to print out the number 0 through 9, well, I could write 1 instruction and I could do that. I don't have to write 10 instructions. What if I wanted to print out the numbers 1 through 10? Well, that's very easy. I just change the value of I. I have a fixed value. This is I. It's going to equal one of these things, and it's going to change every time I repeat these instructions, and I know exactly how it's going to change. So now if we run it, it's going to print 1 through 10. Right? I know how it's going to behave. So step by step, this is just kind of the process of which of these pieces get evaluated and when. So here we go. If we're entering this loop, if we're the computer, the first thing we're going to do is this section here. And I'm going to set a value and a starting value for that variable. We never visit this section again. That's the only time we ever do it, when we start the loop. The next thing I'm going to do is check this condition. Now, if this is false initially, again, this is going to behave just like an if statement. There's no guarantee this loop is going to run. If I do I is less than 0, it's not, right? I is 0. If I do this and I run the code, you'll see that nothing happens. It doesn't actually print anything. Let me clear the screen now. You'll see it doesn't print anything because it's false immediately, and we just exit and we don't do anything. Now, of course, that defeats the purpose. If you're writing a loop, again, typically we would use this when I know how many times I want to do something, and that's not the way we would typically write it. But just so you could see how this behaves and the purpose of that section, right? So check the condition. If this condition is true, we're going to skip this for now. I'm just going to go ahead and do these instructions as step 3. Then we're going to modify I. Then we'll check this again and execute the instruction. And then it's kind of like a circle from here. We'll just repeat that over and over again. Change it, check it, execute. Change it, check it, execute. Change it, check it, execute. And we'll just kind of go through this little circle forever until this becomes false. Recall I mentioned that all of those pieces are optional. None of them are required. So you could do something like this. The semicolons are the only part of the for loop that are required. You have to put this here, but you don't need anything else. And these are just your, let's call them delimiters, right? They separate your sections. That's section 1, that's section 2, that's section 3. All 3 sections are blank. What does that mean? That means do it forever. I'm never going to initialize anything. I have no stop condition, and I don't have to modify anything. I just run forever. That's not a good thing to do. We don't want to do that. The other thing we don't want to do, similar to before, remember when we talked about if statements and things that you don't want to do, or even with functions, we don't want to do this, right? Because this behaves conceptually. This is a block level structure. That means it's a compound structure that you treat as one unit, right? It behaves that way. So how a for loop works is the same way an if statement works. Here's my condition. Let's call it a condition. And what are the instructions that belong to the for loop? Well, if you have a semicolon, if you don't have brackets, then the very next instruction you see belongs to the for loop. Otherwise, if you have a bracket, everything in the brackets. So here, even though we have the brackets, the first thing I saw was a semicolon. So that's the instruction that got associated with this loop. If we were to run this, and you'll see, notice in this case, we don't get any errors, right? If we run it, it won't give us any errors. It just won't behave like we think it should. Let's run it again. And we can see that previously it printed out 1 through 10. Now it just prints out 11, right? Because what we're doing here, we're running the loop. But what are we doing 10 times? We're doing nothing 10 times. And then this is just another random print statement where we just print the value of I. And I was 11, right? That was eventually it incremented it to where it was 11, I plus 1, and well, I was 10. 10 plus 1 is 11. That's what got printed out. So here is a more practical example of how you might want to use a for loop. Let's say we wanted to print the first 10 powers of 2, right? 2 to the power of 0 through 2 to the power of 9. We could very easily do that with a for loop, right? And instead of having to write multiple instructions, we could do something like this. We'll leave this the same. And in here, let's say print, I'm just going to print what iteration we're on. And in iteration, by the way, you'll hear me or you'll see me use this terminology. An iteration is simply one, what do we call it? If this is true, and I enter into this block of instructions, that's one iteration. Whether I skip them or not, right? Maybe in here I have a break or something else to exit it, but it doesn't matter. If this is true, and I begin to execute these instructions, that's one iteration. So this will happen 10 times, right? So this is going to be 10 iterations. The first iteration is going to, I is going to be 0. So iteration count, and we'll do D, and we'll print I. And then here, 2 to the 0th power. Oh. We'll do, so I is 0, right? So we're going to put 2 to the, and we're going to replace that with the whatever I is. So iteration count 0 to the 0 power, and then we'll just print what it is. Print F. Let's do, I don't want to see a lot of percentages. And then we'll call the math function pow to I. Oh, that means we need the math library. All right, so let's just compile this. What is it going to do that to me again? I thought I changed this. Let's do, what is this called? We'll do it for this one. Huh. It should be. What am I doing wrong, everyone? Okay, we'll do it outside of here because JGrass is being silly right now. All right, and we can see here that sure enough, right, iteration count 0, 2 to the 0 power, 1, 2, 4, 8, 16, etc. Right? So we can print the first 10 powers of 2, and that's great. Now, what if we wanted to change this? So let's do this together, or well, I'll give you all a chance to work on it. What if we wanted to change it so that instead of printing TH every time, right? Because that's not always the appropriate postfix, right? So 0th is fine, but that should be ST, right? First, and that should be ND second, and that should be third, and then we're okay up to this point. How could we modify it? How could we modify this so that we could achieve that result with a for loop, right? What will we change to do that? So go ahead and let's do that as an exercise together, and then I'll do it here in just a minute, but I want to give you all a little time to work on it first. All right, did anyone manage to get it to display correctly? Let's try to tackle one of these. So how would let's try to tackle just this one here. How do I handle this instance where I wanted to print second ND instead of TH? Well, how would we do that in general? So forget about wanting to do one or the other. Let's just try to do it period. So how would I print just period 2 to the second power? So we're just printing it on the screen. So one of the things I do, and it may seem a bit annoying, sometimes I'll ask very specific questions. How do I do this one thing? There's actually a reason why I do that. It's very targeted, and the idea is I want you to see how I think about things. And this is kind of how you want to approach programming. When you're trying to solve a problem, you ask a general question. If that's too much, you back up. That's okay. What's a smaller problem that I can, so smaller question I can ask? Maybe I can solve this, and then where eventually I get to the point where by answering all of these smaller questions, I can answer that big question. So that's what we're doing now. I know eventually I want to get to the point where I can print the correct thing. I always want to be able to print the correct statement. But if I can't answer that question yet, at least I know for sure I need to be able to print that statement, period. Right? So that's a smaller thing that I can do that will help me get to that bigger goal. So that's a pretty easy one. How do I print that second? All I want to do is change TH to ND. Well, for now, we'll just print them both. We don't want to do one or the other yet. So we kind of backed up a little bit. So how do we just print it, period? It'll just print every time. I'm fine with that. I just want to be able to print that statement where it has ND in it instead of TH. That's right. So why don't we copy this? We could just copy this statement, and instead of TH, I write ND. And now if we compile this and run it, of course, we're going to have to do it here. If we compile this and run it, we can see that now it prints both of them. If we didn't want it to print both of them, but that's fine. Right? At least we can print it. So we can print ND. Now that we know we're able to print it, how do we control when this gets printed? So I need to be able to print it, and I need to control when this gets printed. So I either want to print ND. For now, we'll ask a very simple question, and we're still going to just focus on this one thing. How do I either print ND or the other one or the other? How could I do that? Yes. You could do an if. Very good. And what would the condition be? So I know I'm going to want to print one of these statements. So what would my condition be to determine which statement I print? Do we have anything in this piece of code here that we know is always going to be true when we want to print ND versus TH? When what is 2? That's right, the loop variable. So I know that every time I equals 2, what do I want to do? I want to print this. So let's just do that. Let's put this here. And if it's not 2, for now, for the time being, then we'll go ahead and print the other one. All right, so we'll leave this very simple. For now, we just want to handle that one use case. And now we see what? Look at that, very nice. So when I equals 2, we printed ND instead of TH, but for every other value of I, we just printed TH, right? Because I is not 2. Now, how could we handle the others, right? We still have ST and we have ST and first, right? We have third, RD. So how do we add those two? We've already seen how we could handle this, right? What might we do to add those two? We can just do else if, right? So if it's 2, then we're going to print ND. But, and what could we write here for our if statement? When would we print RD? If it's 3, right? So if I is 3, and what can we do? We can just take this, we can do the same thing we did last time. We'll just copy this and paste it, and we'll change it to RD. That's third, first, second, third. Oh, we forgot about ST, right? So we have to do something for ST. Let's make this an else if. And when I is 1, right, we want to print ST. To the, let's see if we did it correctly. And here we go. Oh. What did I miss here? So here's the iteration count. And then I'm either going to print 2 to the first, if it's a 1, 2 to the second, if it's a 2, 2 to the third. Oh, what did I miss? I missed my last else, right? So this is always going to happen no matter what. I don't want it to always happen no matter what. I only want it to happen if none of those other things are true. And here we go. So 2 to the 0, 2 to the first, second, third, and then we have everything correctly. So we can see how with a for loop, hopefully that exercise was helpful, and we can see how with a for loop, we can take, right, some instruction, and we didn't notice we didn't have to write those instructions 10 times, right? I wanted to calculate 10 powers of 2. Now I did have to put some conditions in here because I wanted to do something slightly different based on those values of I. But for the most part, we have either identical or almost identical instructions, very similar instructions that we're just executing over and over again, right? And we only have to write the instructions one time, and then we let the loop take care of that for us. Nested loops. A loop, just like an if statement, is just another construct in C. It is possible to have a loop inside of a loop. Now, if you do that, if you have a loop inside of a loop, this entire loop here, let's call it the inner loop, it's the one on the inside, this entire loop counts as one instruction. Remember, we're viewing this, even though we're repeating something multiple times, we're viewing this entity, let's call it an entity, as one unit, even though we're going to do something multiple times. So that means every time we repeat this loop, this one gets repeated 5 times, right? J is going to be 0 through 4. Then we go back and I is going to be 1 and J is going to be 0 through 4 again. Then we go back up here and I is going to be 2 and J is going to be 0 through 4 again. So, oh, I thought I had it here. I will do it for raise. So just if we had to guess, looking at this and listening to that brief explanation of how nested loops work, and with our limited knowledge of how loops work, what do you think is going to be printed here? So here is one print statement, I times j, and then it just, we're going to print some value. It's going to be I times j. What do we think is going to be printed as a result of executing this? If I were to run this code. So let's go through, and this is another thing that, believe it or not, I still do. When I'm trying to understand what loops do, I will still do this. You have these variables that are dynamically changing. They're not fixed, and it's a little bit abstract, right? That process. So what you can do to make it more concrete, anything we can make more concrete makes it easier for us to understand what's happening. As we can go through and we can just write what these values are, right? We can document those values. So let's say I'm trying to understand what I think this loop is doing, how it's behaving. I don't understand how it's behaving. I'm trying to get it. What can I do? Well, I know I've got two variables, I and j, and they have values. So I'm going to write I and j here. And when I go through this loop, if I'm executing this code, initially I is going to have a value of what? 0. So let's just write, iteration 1 and I equals 0. And we're going to get down here and we have another loop. And that's going to have a value too, right? So what is the value of that going to be? 0. And this is also a loop that has to complete. So this is going to have multiple iterations. So I'm still on let's do this iteration 1 of outer loop, right? And here we're going to go, well, here's iteration 1 of inner loop. So at this point, we have the same variables, right? We still have access to I and j. And those are the values. And now that we have these concrete values in front of us, what do we know it's going to print at least the first time we execute it? Is to look at the print statement. So what is I? And what is j? So it's going to print 0 times 0 and then colon 0. So there's iteration 1. Now we have to do 5 iterations of that outer loop. So let's do iteration 2. Now, I is still 0, right? Because we haven't gone through the next iteration of that outer loop yet. But what is j now? Because we understand how loops work. Okay, now if we had to describe what that would print, what is it going to print this time? It should be easy now, right? 0 times 1 equals 0. And now we probably don't have to do this anymore, right? So we can kind of do this until we see the pattern. And now we already know, oh, it's going to be 0 times 0 through 4, and they're all going to be 0. Then this is going to change to 1, and it's going to be 1 times 0 through 4. Then this is going to change to 2, and it's going to be 2 times 0 through 4, etc. And with that, I think we are out of time. We'll do an exercise on Wednesday, and then after the break, we'll finish with while loops. Do you all have any questions for me? All right, have a good evening, everyone. I'll see you on Wednesday.